This is part 2 of converting a recurring decimal to a fraction. In part 1, we were able to demonstrate how to convert a recurring decimal like 0.4 into a fraction. In part 2, we're looking at a more complex recurring decimal. What happens when we have 0.345 with a repeating 345? Once again, we can use the same method. If we say that x is going to be equal to 0.345, we can multiply this decimal to get 345 out the front. In order to do that, if we multiplied by 10, we'd get 3.45. If we multiplied by 100, we'd get 34.5. If we multiply by 1,000, we can move our 345 out to the front. So that means we've now got 1000x being equal to 345.345 with our repeater. Now, because we've got the 0.345 repeating on both of these, 1000x is equal to 345. Let's clarify. There we go. Is equal to. So that means that now our 999x is going to be equal to the 1000x minus the x, which is going to leave us with just 345, because our decimal component for both numbers cancels out. We can then do some simple division, and we find that x is going to be equal to 345 over 900. Divide both sides by 999 and you end up with a fraction for our recurring decimal. This is our final video now for recurring decimals into fractions, and what we're going to look at is our third example. What happens when we have a decimal like 0.26 where the 6 repeats? Once again, we can look at this decimal and we can move both the 2 and the 6 out the front of the decimal. If we say that x is equal to 0.26, then we can get 10x being equal to 2.6 repeater. Once we've got our 2.6 repeater, you'll see that we can once again do some magic with algebra. We can get 9x being equal to our 2.6 repeater minus 0.26 repeater. So if we do some subtraction here, 2.6 repeater minus 0.26 repeater, you'll see that all of the 6's to the right hand side here are going to go away. However, we're going to have an extra bit of digit here. So if we have 2 minus 0 is going to leave us with 2. However, the 0.6 minus 2 is going to leave us with 0.4. Our 6's from that point on are going to all disappear, and our 6's from that point on are all going to disappear. And so that means we now have 9x being equal to 2.4. And we can once again do some magic. This is now our third example of converting recurring decimals into fractions. What happens when we have a decimal like 0.2 and then our repeating digit is just the 6? You'll remember that we first of all set that equal to x, and just for some clarification, you'll remember that this is the same as 0.2666, and then that goes on forever and ever. You'd be left forever writing 6's. In this case, what we want to do is get both the 2 and the 6 into the left hand side of the decimal place. So in order to do that, we'd have to multiply once again by 100. And we can then see that 100x is equal to 26.6. And then we'd have that repeating forever and ever. You remember that we can shortcut that just by putting a dot over the top of A6. If we subtract these two values, we end up with 100x minus x, and that's going to leave us with 99x. Over here on the right hand side of our equation, we've got 26.6 repeater minus 0.26 repeater. Let's have a look at that in a traditional subtraction. When we do our subtraction in this case, you'll see that all of these 6's to the right hand side here cancel each other out. We're left with a 6 minus a 2. This is the subtraction. 6 minus 2 leaves us with 4. We put our decimal place. 6 minus 0 ends up with 6, and 2 minus 0 ends up with 2. And so we have our final fraction being 26.4. Once we've got our 26.4, we can then multiply both sides of this by 10, and if we multiply both by 10, we're going to end up with 990x is equal to 264, and that means that x, if we divide by 990, is going to be equal to 264 over 990. You can then simplify this fraction to find a simpler result.